Hi everyone, I'm Cheryl. In this problem, we're going to be finding a power series for the natural log of x plus 1. And we notice also that the natural log of x plus 1 is the integral of 1 over x plus 1 dx. In addition, we're allowed to use the fact that 1 over 1 plus x can be written as the power series. So let me rewrite this. The power series, which we sum from n equals 0 to infinity, of minus 1 to the n, x to the n, dx. All right, so we'll begin by integrating that power series. So what I end up with is a series from n equals 0 to infinity of minus 1 to the n power and x to the n plus 1 all over n plus 1 plus my constant of integration. Now I'd like to find out what the constant of integration is at this point. So I want to see where my power series is centered. This particular one is going to be centered at 0. So let's see what happens when I substitute 0 in for x. I'm going to have the natural log of 0 plus 1 equals the sum from n equals 0 to infinity of minus 1 to the n, 0 to the n plus 1, all over n plus 1 plus a constant. On the left-hand side, I have the natural log of 1, and the natural log of 1 is 0. And look at the right-hand side. This whole summation is nothing but 0 plus 0 plus 0, and so on. So that whole term goes away as well. And so my constant of integration was a 0, which means that my function, the natural log of x plus 1, can be written as a power series n equals 0 to infinity of minus 1 to the n, x to the n plus 1, all over n plus 1. And remember, plus my constant of integration, but we know that that's a 0. All right, so now that I have my power series, I'd like to find the interval of convergence. So I'm going to begin by using the ratio test here. And if you remember, for the ratio test, we're going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 all over a sub n. If this limit is less than 1, it converges. So let's go ahead and take a look at what happens. We've got the limit as n approaches infinity of the absolute value of a sub n plus 1. That's going to be minus 1 to the n plus first times x to the n plus 1 plus 1. So that's the n plus 2 power. And I'm going to divide that by n plus 1 plus 1. So again, that's n plus 2. I now need to divide by a sub n, which is going to be the same thing as multiplying by the reciprocal of this. So this is going to be an n plus 1 all over minus 1 to the n and x to the n plus 1. Okay, let's simplify that piece that's inside the absolute value. I've got the limit as n approaches infinity of negative 1 to the n plus 1 all over negative 1 to the n. That's just going to give me a minus 1 because those cancel. And I also can cancel x to the n plus 1 with x to the n plus 2 and just have an x in my numerator. I also have that n plus 1 in my numerator and my n plus 2 in the denominator. Okay, now the next piece I'm going to worry about is that absolute value. I'm going to notice that I can take the absolute value of negative 1, which just becomes a 1. I can also take the absolute value of n plus 1, which is just n plus 1, and the absolute value of n plus 2, which is just n plus 2. Those two expressions are always going to be positive. So the absolute value of negative 1 is a 1, and I'm going to have an n plus 1 and an n plus 2 that I can just pull out of the absolute value. Now, x, since I don't know what x is, that has to remain inside the absolute value. All right, so let's take a look at the limit. I'm taking the limit as n is approaching infinity. So I don't really care what happens with x here. So this will just be the absolute value of x. And now I'm taking the limit as n approaches infinity of n plus 1 over n plus 2, which is simply a 1. So I end up with the absolute value of x. Now remember, in order for the ratio test to tell me that I have convergence, this particular expression has to be less than 1, which means that x is going to be between -1 and +1. So I have a pretty good interval of convergence, but I still need to test those endpoints. So let's check and see what happens at x equals -1. So what happens when x equals -1? Well, what does my series look like then? Well, let's go back to the original series, and I'm going to have the sum from n equals 0 to infinity of -1 to the n and a -1 to the n plus 1 all over n plus 1. This series is going to be the series taking the sum from n equals 0 to infinity, and I'm going to have a -1 to the 2n plus 1 all over n plus 1. And notice that 2n plus 1, that's guaranteed to be an odd number. So I can further write this as the sum from n equals 0 to infinity of -1 all over n plus 1. Now, if you consider this series, and if I factor the minus out, and I look at the series 1 over n plus 1, I can use the limit comparison test and compare it to the series 1 over n and say that this series diverges. And we'll say it diverges by the limit comparison test. On the other hand, we also need to check what happens when x equals a +1. When x equals a +1, my series will be the sum from 0 to infinity of -1 to the n and 1 to the n plus first power all over n plus 1. This series is going to be the series from where I'm summing from 0 to infinity of -1 to the n all over n plus 1. This is an alternating series, and if you use the alternating series test, you'll discover that my series converges. So this converges by the alternating series test. So what does that tell you about the original problem? Well, my original series is going to converge on the interval from -1 to +1, including +1. I hope that was helpful. Thanks.